the space weather this week. In this weekly bulletin, we bring you the latest conditions in space weather, including the solar and interplanetary events, phenomena, and of course all the news related to it. If you want to know how the sun is affecting our Earth and its life here, what are the threats that it poses and understand their implications, keep an eye on our channel, the space weather this week. The sun is the source of all space weather events, and so we should start with the sun. This week, on 11th of April, the sun has shown a massive explosion on its surface. The S-shaped magnetic filament at the base of the explosion is a classic sigmoid structure. Solar magnetic fields often assume this shape just before they explode. One study shows that sigmoid precursors are present over 50% of the CMES. Indeed, shortly after the explosion, a full halo cheme emerged from the blast site. The northwestern limb of the sun has been found to be seething with activity. On the 15th of April, there had been massive solar flares with large spills of debris flying into space. NASA's Solar Dynamics Observatory, SDO, recorded this sample during the early hours of April the 15th. The source of activity is a far-sided sunspot region. It is more active than it seems because all of these flares are eclipsed by the edge of the sun. Some of them actually may have occurred in X class. Spot numbers are their dark regions on the surface of the sun. The sunspot numbers exceeded 100 mark for at least 3 times in the last week. The highest tally it reached was just short of 140, which is quite high for the current trough of the solar cycle period. It looks like the sunspot group we spoke about just now is responsible for this. As a result, we may expect a high sunspot number in the next fortnight, when this region will again face the Earth. Currently we are experiencing a lowest value over the 27-day solar rotation period. Over the last 7 days, the sunspot number remained quite nominal, around 30. However, in the coming week as the sunspot group will be appearing towards the Earth, we may find this number to be rising to a number maybe above 100. F10.7 is the index of average radiation from the sun. Accordingly, the F10.7 numbers have also shown similar variations. Over the last solar rotation period, it has shown a high on around 1st of April, which reached up to 160, while at the end of this week we had also hit a low. This week's radiation remained consistently low at about 100. The sun constantly emits particles and radiation. It includes the protons and electrons as well as the X-rays. This week the proton flux remained consistent between 0.3 to 0.4 proton flux unit. Obviously, the higher energy particles were lower in numbers. The X-ray radiation was also consistently low. However, towards the end of the week we found an abrupt increase in the low energy flux. It occurred on the 16th day of April. The solar wind is the continuous flow of charged particles from the sun which permeates the solar system. The particle content from the solar wind abruptly increased earlier in the week to about 40 particles per cubic centimeter of volume. The nominal number is, however, about 6 to 10 particles per cc. The effect of the CME was observed on late 15th, and on this date the particle numbers also increased to a high of about 30 particles per cc. On other times the particle numbers remained around the nominal. The solar wind velocity increased from lower to higher values across the week. At the beginning of this week, the solar wind velocity started with a nominal value of 350 kilometers per second, which is considered as a slow wind. By the third day, it abruptly increased to 500 kilometers per second. Over the rest of the period it remained allowed this value. The radius of the magnetosphere gets modulated by the solar wind. The radius is defined by the impact of the solar wind pressure onto the magnetic field of the Earth. This week, the radius of the magnetosphere increased in the early hours of the 9th of April. But following this day, it again reduced to its typical value of 10 and remained consistent over the week. Solar wind carries with them magnetic fields of the Sun. These magnetic fields pass through the interplanetary space and are called the Interplanetary Magnetic Field, IMF. The Z component of the IMF, that is IMF-BZ, remained near zero for most of the time. However, there had been an abrupt turn to negative values, which occurred on the 10th and early 15th. The DST, or the Storm Time Disturbances, is an index which shows how the geomagnetic field near the Earth's equator has been changed by the solar activities and the space weather parameters. Particularly, this is done by the formation of ring current. This week, DST showed a significant low over the period. The DST showed a minimum value, which went to minimum on 15th of April, when it reached -80 nanotesla. This was a consequence of the CME that occurred on the 11th of April. It indicated the formation of strong ring current and moderate geomagnetic storm. The plant, that is, the KP index, shows the magnetic condition on the Earth. The ring current significantly changed the geomagnetic condition of the Earth over this last 1 week. The KP values reached to a +6, indicating a G2 level of storm. So these are the space weather conditions we experienced last week. Thank you very much for being with us. The presentation has been made by spaceweather.tech. Please like and subscribe to us for receiving space weather news every week.